All right, ladies and gentlemen, we begin with Chapter 9 and Lesson 9.1. We're going to talk about the real numbers. And so in this case, we're going to talk about number sets more than anything. And so our job, when we are finished with this chapter, the three main goals that I would like you to be able to do, at least this lesson, is to determine if a number is rational or irrational, identify the number sets of which a number belongs, and then we're also going to have to be able to find a number in between two others. And again, I'll show you what those things mean as we go along here. So let's talk first about the real number family tree. Okay. So you're going to fill this diagram as we go along. And our number system, the numbers that we deal with, that we work with every day, are broken up into different types of numbers based on their characteristics. And so we are going to take the time to identify those numbers and what sets a number falls into. Okay, so we're going to first begin with the real numbers. Okay, and so please fill this out as we go along, and I'll be going back and forth between this diagram and other slides. So be prepared to flip around in your notes. Okay, so the real numbers. The real numbers, by definition, are the set of rational or irrational numbers. And we will talk here in a second about what rational numbers and irrational numbers are. Okay. Basically, this is not a mathematical definition, but pretty much every number that you ever work with is part of the real number set. Okay, so understand that in this class and in our middle school and high school education, for the most part, until you get into some upper level mathematics, you are dealing with numbers, with real numbers. Okay, there are some exceptions that we will get to a couple times in here, but down the road you'll run into other types of numbers as well. Okay, so we have our real numbers. Real numbers are broken into two categories. Okay, so you'll notice here we have our little family tree. You can either go to the left or go to the right. We're going to start by going to the right with what we call irrational numbers. Okay. Now the definition of irrational numbers, you want to get this down. It's the set of numbers, that should be an S, that can only be written as decimals that do not repeat or terminate. Okay. Now we have some examples of irrational numbers, and if you want to put these even as a test, put them in a calculator and see what happens. Okay. For example, the square root of 5. Okay. Now, if I put that into a calculator and I were to hit the square root key, you would get a number that goes 2.230,679, and now this is where the calculator cuts it off. At least a little basic calculator cuts it off. This number here actually is a non-repeating, non-terminating decimal. Goes on forever, never repeats, never comes to an end. And so in this particular case, we're talking about an example of an irrational number. Okay. Our numbers that repeat or terminate, we'll get to in a second. So this is an example. So a lot of times, a lot of the square root numbers, like the square root of 7, it also is an irrational number. The square root of 7 is approximately 2.645751.13, and then again the calculator it will cut it off at that point, but it goes on forever. So our sets of numbers that do not repeat or terminate, those fall into our irrational number sets. Okay. So now we work to the left side of the table, and that's one thing that you have to understand first off, is that it is not possible to go both left and right here. Left and right here. Once we have a real number, it will either go to the right and be irrational, or it will go to the left and start working down the left side of the table. So we have our rational numbers. Now rational numbers, by definitions, and this is actually not the mathematical definition, but this will be the definition that we work off in this class, is it can be written as a fraction. Okay? And more specifically, the denominator and the numerator have to be rational numbers themselves. They have to be nice whole numbers or integers or something. We do have some weird fractions that come into play, but generally for our purposes, is if you can write the number as a fraction, it's a rational number. Okay. So again, real numbers can either be our rational numbers, things that can be written as a fraction, or irrational numbers, which pretty much are things that can't be written as a fraction. Okay. And then we work further down the table. We have our integers. Okay. So our integers is the set of whole numbers and their opposites. Okay. And so our integers, you'll notice, and these are just some of the examples. You have 0, 1, 2, and then you would have 3, 4, 5, 6, 7, 8, 9. The numbers that come out to nice whole numbers going up as we move to the right along our number line, and as we move to the left down our number line. So our negative whole numbers, so to speak, are part of our integer sets. And then we move a little further. Under the integers, we have whole numbers. Okay. The set of whole numbers is the set of natural numbers, including 0. Okay. So you'll notice we've actually taken the integers and we've cut off part of the integer set to make our whole number set. So as we move down that diagram, we're getting more and more specific. Okay? So in this case, we got rid of the negatives that would be over here to the left. We now have 0, 1, 2, 3, 4, 5, 6, 7, 8. Again, it will continue as we go to the right. So as we move down the table, a little bit more and more specific. The most specific are our natural numbers, and those are what you might call our counting numbers. And those are the ones that you learned to count with when you were a kid. Again, when you learn to to count, or if you've helped a child learn to count, we typically start at 1 and go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. We don't usually start at 0. So you'll notice that the natural numbers are the same as the whole numbers, with one exception. The whole numbers included 0. The natural numbers do not. Again, natural numbers are the things that we learned to count with. Okay, so now we have our diagram. Let me pull this out, but you have yours. Okay, one of the things that we want to be able to do is identify which number sets that a value falls into. So the number 10, for example, in this particular case, what set does it fall into? All right. So real numbers. Is 10 a real number? Well, yeah, sure it is. It's real. Okay. So that's the first thing. It is a real number. We work with 10 all the time. Okay. Now, it's either going to be rational or irrational. It can't be both. Now, I would go for the definition of rational numbers here and try to determine whether we can make it into a fraction, which we know all whole numbers can be made into a fraction by simply placing them over 1, which obviously means, well, there's my fraction, so it is rational. So I will write that down. Okay. And again, one of the things that you may have to do as you're identifying numbers is be flipping back to the definitions. Okay. Integers. Is this an integer? Well, if I flip back to my definitions, and so let me find there we go, my definition of integers, the set of whole numbers and their opposites. So on my set, 0, 1, 2, if I were to continue counting, I would run into 10. And so here, again, flipping back and forth, this is also an integer. INTEGER. Okay, so it's an integer as well. Is it one of our whole numbers? Well, again, if you go back to the definition of whole number, a whole number is it starts at 0 and goes up as we move to the right on the number line by whole values. So yes, it is also it will fall in the whole number set. Okay, so it is whole. Is it one of our natural counting numbers? Yeah, it is. We learned to count with that one. And so it is also natural. So in this particular case, 10 fell, obviously it was a real number, and then went down the left-hand side of our table. It was not an irrational number. Okay. So now the square root of 10. All right, so we had 10, and now we're doing the square root of 10. Well, is the square root of 10 a real number? Well, yes, it is. I can put it into a calculator, And if I give you the value of the square root of 10, it is approximately 3.16. And in a it will continue, but this is one of those non-repeating, non-terminating decimals. It goes out until the calculator cuts it off. So the calculator cuts it off, but it will continue on for good. And so because it's a non-repeating, non-terminating decimal, it falls on this side over here. So therefore we have a real number that is irrational. A-T-I-O-N-A-L. And the nice part about this is that, again, our real numbers either go to the left or to the right. They don't do both. So once I'm over here at irrational numbers, I can't go any further. I cannot jump back over to this side. That is a no-no. Okay? So this is real and it's irrational. So if I have a, let's see, negative 10. So, and in this particular case, is negative 10 a real number? Well, sure it is, so real. Is it rational or irrational? Now, I usually check to see, I usually go to the rational side first and go, okay, can I make this into a fraction? Yep, sure, so it's rational. Rational, okay. It's got to be either or here. There is no both, so because it's rational, I know that it can't be irrational. Is it one of my integers? Is it one of my positive or negative whole numbers? Well, yep, it is. It is an integer. So I will write that down. Okay, so we've got real, rational, integer. Is it a whole number? Well, the answer to that is no. It is not a whole number. Our whole numbers are 0 and then positives. And so in this particular case, it's not whole. If it's not whole, it can't be natural. Okay, once we get to a point going down this left-hand side, if we can't go any further, we're stuck. So it's real, it's rational, and it's an integer. Now we also have to talk about the thing called the density property. And that is that between any two real numbers, there is always another number. Okay? And so one of the things that we're going to do is, if you're ever stuck at trying to find a number that falls between two others, take an average. If you add them together and divide by 2, that will find the middle. Okay, which now then you can even go the middle of those and the middle of those and the middle of those, and you can always find a number between two other numbers using the density property. So in this particular case, we are going to find a number between 1 1/3 and 1 2/3, which may not seem like you can because they seem like they're sitting right next to each other on the number line, but in fact they are not. Well, they are, but there is space in between them. And now if you don't know between 1 1/3 and 1 2/3 what falls between them, then add them together and divide by 2. Take their average. Now the nice part, because these are both 1 for whole numbers, I only have to deal with the fractional part of them. It's going to be 1 and something, so I can just, in this case, ignore the 1 for right now. So if I add these together and I divide them by 2, so this will be 3/3, okay? But if I divide 3/3 by 2, and we have to go through our steps of dividing by 2, I take the second fraction, I flip this upside down, right? So 2 over 1 becomes 1 over 2. I'm just going through my steps for dividing fractions. And then go ahead and multiply out. 3 times 1 is 3. 3 times 2 is 6. 3/6 is a half. So my fractional part will be a half. So what I have found is 1 1/2 is halfway between 1 1/3 and 1 2/3. So if you ever need to find a number in between two numbers, just take their average, add them together, and divide them by 2. And that will find the middle. And then if you need to go even further, add those two numbers together and divide by 2, and so on. We can always take an average of two numbers. That will give us something in the middle. So that's what I'm going to encourage you to do. If it's not obvious to find a number in between two others, add them together, divide them by 2. All right, time for your practice. Obviously, if and when you need help, you come and see me. Good luck.